My name is Gaspard Laouénan, and today I will present you a paper about performance and ergonomics of automated versus manual validations for AR-supervised industrial operations. The work was done with Jean-Yves Didier from the IBISC laboratory and Paul-Éric Dossou from ICAM Grand Paris Sud. Here you can find a quick summary of the presentation. Augmented reality has proven to be a viable solution compared to paper instructions for the supervision of maintenance procedures in industrial contexts, to reduce error rates and increase overall performance. With the use of computer vision and cyber-physical systems, the validations of specific tasks in AR environments can be automated to increase process quality even more. New standards such as WebXR also emerge, offering opportunities to address issues related to ease of reconfiguration and integration of various devices' capabilities. However, in the context of Industry 5.0, the impact of such methods on operators' acceptance has yet to be estimated, especially knowing that user familiarity with AR affects performance and satisfaction. Ergonomic brakes need to be lifted to ensure the successful digital transformation of companies. The main focus of our study was automated validation of AR-supervised operations. Thus, we want to address the following issues. How does the theoretical impacts of such techniques compare to manual validation regarding performance and cognitive ergonomics? How can the impact of design choices for the validation of AR-supervised operations can be quickly estimated to better address Industry 5.0's issues? And also, how can the same capabilities be easily implemented on different platforms to test the design choices in various contexts? Our approach consists of a Wizard of Oz experiment to simulate automated validation, with an evaluation of various metrics related to performance and ergonomics. And to support the experimentation, a WebXR prototype was developed to help testing validation mode on multiple devices. SCRAM, our prototype, is based on WebXR. It is also based on arcs.js, which is a fast prototyping framework for AR applications. The architecture of the experimental prototype allows both the supervisor and the participant to validate tasks. This way, we were able to conduct the Wizard of Oz experiment with the supervisor simulating the automated validation process. We tested two factors to compare four modalities of validation: a device factor with tablet versus head-mounted displays, for which we used HoloLens 2, and a validation factor, automated versus manual. The experiment was done with 24 participants using the Latin square method to test all possible permutations, and here you can see the experimental protocol with the four modalities being tested successively. Operations were evaluated through 5 different criteria: performance with the completion times and error rates, task load using the raw NASA task load index, usability with the system usability scale, and user acceptance with the determinants such as perceived ease of use and perceived usefulness to predict the behavioral intention based on the technology acceptance model. We formulated the hypothesis considering that the HMD and the automated validation would give better results overall for each metrics. For the user acceptance, we also used other determinants such as computer self-efficacy, computer anxiety, and computer playfulness to help characterizing the sample demographically. We also made the assumption that automated validation would reduce the perceptions of external control compared to manual validation. Here you can see the object that was handled by the participant, which consists of a small robotic gripper. The operations consisted of 6 steps, which took on average 5 to 10 minutes for the participant. Here you can see the view of the user interface for the prototype, with the HMD on the left, and here the setup with the tablets on the right. For the manual validation modalities, the user was asked to confirm the validation using a small box on the web page, both for the HMD and the tablet. And on the other hand, the color of the 3D model was adapted depending on the task type, with red for removal operations and green for assembly operations. Among the 24 participants, we got engineering students, PhD students, as well as engineers between 20 and 26 years of age. The TAM determinants showed that they are usually at ease with general public technologies. However, the one thing to notice is that the sample is globally not familiar with AR, with 2/3 having no experience at all with XR, and less than 15% using XR technologies regularly. Generally, this is somewhat close to the general population in industrial contexts, as immersive reality isn't yet broadly implemented in industries. For the completion times, we didn't find any significant difference between automated and manual validation. However, we found a significant difference between HMD and tablet, with the HMD being 16% slower. If this contradicts our assumption, it can be explained with regard to the sample's low experience with AR, as it then correlates with results from the literature. As far as the error rates are concerned, no significant difference for each factor was found, suggesting that the information given to the participants in both contexts were somewhat equivalent. In the end, most of the mistakes were due to confusions of symmetrical and similar parts. Regarding the task loads, no significant difference for each factor was found. The average scores indicate that the task complexity was low. As for the completion times, the system usability scale didn't highlight any significant difference between automated and manual validation, but showed significant difference between HMD and the tablet, with the tablet being considered 16% more usable. Again, this correlates with results suggesting that prior experience with AR affects performance and user experience. Regarding the user acceptance, results for the perceived ease of use correlate with the results for the usability. In particular, although the hypothesis for the perceptions of external control regarding the validation factor was verified, it didn't translate into any significant difference in perceived ease of use between the two validation modes. As far as the perceived usefulness is concerned, no significant difference was observed. To summarize the results, it appears that the low experience of the participants with AR affected their performance and user experience negatively for the modalities with the HMD compared to the tablets. However, in both contexts, automated and manual validation ended up giving similar results. Indeed, despite noticing specific types of unsuccessful and unwanted interactions in the AR environment of the HMD that clearly disturbed the participants during the operations, the observed differences in completion times regarding the validation method turned out to be insignificant. The smaller proportion of experienced participants that usually benefit from the use of AR in these contexts may in fact have balanced the overall results. From another perspective, if one may consider leaving manual validation of specific tasks in AR-supervised contexts, we recommend watching any kind of interactions where the user can struggle, especially when they're inexperienced. For example, the user can struggle to properly evaluate the distance between the finger cursor and the virtual interface, or the gray cursor of the HoloLens 2 can interact with the interface without the user noticing. Regarding the information given to the participants, the static 3D models combined with the 2D operating modes turned out to produce similar results as the 2D operating modes alone, suggesting that the AR interface can be improved. Finally, the additional determinants of the user acceptance did not particularly correlate with the main determinants results, suggesting that the extended technology acceptance model might not be more relevant than the core model for experimentation in lab conditions. Overall, we recommend that future research should consider user familiarization with AR technology to improve performance and user experience. Hybrid design combining manual and automated validation could also address some issues, especially by finding ways to alert the user to prevent mistakes rather than by validating the compliance. Future development will thus focus on implementation of automated validation capabilities and efficient ways to alert operators.